Welcome to PCIM in Nuremberg. I'm here at the booth of Henkel and I'm together with Ram. Hi Ram, good to have you here. Please, first of all, introduce yourself and your company briefly to our audience.
Yeah, Jorgen, nice to meet you. My name is Ram Trichur. I'm the Vice President of Semiconductor Sales in Henkel Corporation based out of Irvine, California. Henkel is a company serving semiconductor packaging materials industry for more than 50 years. We have products in wire bond packaging and in advanced packaging applications. Some of our wire bond packaging products, especially used in die attach, are known as the gold standard of the industry for both the reliability and performance. And we have a portfolio serving encapsulation materials, underfill materials, adhesives, and thermal materials in our portfolio for semiconductor packaging.
What do you see as the major trends in power electronics nowadays, and what does this mean for your company, for your products?
Very good question. So if you look at the drivers for power electronics and power conversion devices, they mainly follow these trends. One is maximizing power efficiency, improving reliability, reducing weight, size, and volume in many applications, lowering cost, and also improving reliability and thermal management, especially in high power devices. So as you can see, there is plenty of opportunities for a materials innovator like Henkel Corporation to serve these applications, especially in improving the efficiency, improving the reliability, and also the performance of the device using our portfolio.
Have you got some examples for me about where you implemented these trends?
Definitely. Maybe I can walk you through two examples. Yeah, maybe the first example I want to give you is in power modules used in EV applications, and the next example I probably will talk about some data center applications. Okay. So if you take power modules used in EV applications, and if you take a cross-section of the device, it starts with the die, which is attached to a substrate, which is in turn attached to a base plate, and then attached to a heatsink. And if you see the drivers, that driver of these fundamental power electronics trends impacts all of these layers. So let me start from the die. So the die is attached to a substrate traditionally using aluminum wire bonds. And in very high power conditions, high current conditions, we've seen our customers say the wire bonds, aluminum wire bonds especially, fail. So these are being converted into copper clip or copper foil based applications. And if you look at the die itself, traditionally these are silicon based dies. And now with the call for improving power efficiency, these are being converted into wide-bandgap semiconductors like silicon-carbide, and also in the future gallium nitride. So when this moves to these wide-bandgap devices, these devices run at much higher junction temperatures, and also there is a lot of heat flux going through a very small area. What it means is now there is a lot of heat going through. So traditionally this die is bonded to a substrate using a solder, and now solder cannot be used anymore. So now it's being converted into a sintering material. So there's another need. And in that same way, the substrate was traditionally bonded to the base plate using sintering or solder materials. Now that is also being converted into sintering. So again, thermal management, performance, efficiency are all the major drivers for this inflection. So that's in EV power modules. But now let's move to data center power modules. So here, in data center, the main devices are CPUs and GPUs. Right now, the power consumption is around 1,000 watts, 2,000 watts. But if you look at devices in 2030, they're moving to upwards of 4,000 watts. So there's a lot of power and current requirements. And all of these are delivered to the CPU and GPU using voltage regulator modules. And these voltage regulator modules are small devices that are around all these processor units. And they have this power conversion device on top of which there is a inductor or also capacitors attached. And traditionally they are attached using solder materials. And when there is high power consumed and used, solder is inefficient at these, and they're also being converted into sintering. So as you can see, in power module applications in EV, in data center, there is a lot of opportunity for material suppliers like us to enter with the new classes of products. So that's exactly where Henkel's involved.
Thank you.
Yeah.
Yeah, we're here at the PCIM show. So what do you have here? What are your highlights?
Yeah, great question. Actually, believe it or not, my first PCIM ever. So, and I'm super impressed with the show and the engagement we've had in the last 2 or 3 days. So what we're exhibiting mainly are showcasing our high thermal die attach and our sintering solutions. So Henkel has a very large portfolio of high thermal die attach materials and also sintering solutions from our first product that was introduced way back in 2009. So what we're showcasing here is in high thermal die attach, we have a portfolio covering all the way from standard thermal die attach from less than 2 watt per MK all the way to 100 watts. So our standard die attach covers the entire range and multiple die sizes. We recently launched several products along these thermal conductivities using a technology called phase-induced polymer separation, or polymer-induced phase separation, PIPS technology. So we launched certain products like that in our die attach, which is used for high thermal devices, and then also in sintering applications, we made significant breakthrough in pressureless sintering applications, especially for copper-based substrates. So we're promoting that to our customers. It is our product called the 8068TC that is in late stage qualification. And then for pressure-assisted materials, Henkel is focusing mainly on copper-based pressure assist sintering material. So here it's used in power modules. Again, people are very concerned about silver prices with large volatility and fluctuation in silver. There is huge force from the industry to move towards copper-based. Henkel is one of the leading companies working with all the leading players in copper-based pressure assist sintering, and that's what we're promoting. And that's what you see in this poster also here.
Thank you very much. I wish you a good show.
Thank you, Jorgen. Thanks a lot. I really appreciate it.